like, share, subscribe.
Hey y'all, welcome back. Today we're going to review what we learned in Unit 2, which is all about graphing linear equations and inequalities. So this first question is asking for us to find the slope, and we can find the slope of a graph using this idea of rise over run. So essentially what we're going to do is we're going to compute the change in y over change in x, but to do so visually, we're just going to look to see how many units we go up or down, and then how many units we go to the right. So in this problem, you can see that we are going down 4 units. So I'm going to say that my change in, let's see if we got a change here. There we go. Where'd it go? There we go. My change in y is going to be -4. And then my change in x will be however many units I'm going horizontally here. So my change in x, if I'm counting 1, 2, 3, 4, 5, 6, my change of x is going to be 6. So my slope, which is change in y over change in x, let's go ahead and write that down. Change in y over the change in x is going to equal -4 over 6, and that'll reduce to -2/3. So that's going to be the slope of this line. For number 2, we're looking for the x-intercept of the function, and if you're looking back at number 1, the x-intercept, and we're just going to use this as like a little visual, is the point at which you're crossing the x-axis. So like a number 1, the x-intercept would be at 3, 0. But no matter where it is, wherever the line is going to hit the x-axis, for every point that's on the x-axis, the y-coordinate is 0. So the strategy here is to plug in 0 for y, which, if you're using function notation, is just your f of x. 0 is going to be 9x minus 18. And then we're going to solve this for x, and that'll give us our x-intercept. So I'm going to add 18 to both sides of my equation, and that'll give me 18 equals, let's see here, 18 equals 9x, and then I want to divide both sides by 9. So divide by 9, divide by 9. And 18 divided by 9 is going to be 2, and so that's going to be my x-intercept here. So the x-intercept is going to cross the x-axis where x is 2. When we're talking about x-intercepts, it's usually good to write it as a coordinate, so I'm going to write it as 2, 0. So there is number 2. Number 3 is asking us to graph the linear function -1/3 x plus 3. So this is in y equals mx plus b form. That's our slope-intercept form, and it's named that because you have the slope, which is the coefficient of x, and the y-intercept explicitly written out in the equation. So we'll start by plotting the y-intercept at 3. So that's going to be right about here. And then I'll use the slope to find the rest of the line. Since the slope is -1/3, I'm going to go down 1 over 3 and plot that point. I can't really go any further because it's going to be off the grid. So you can continue this pattern backwards to find more points. And I'm going to just plot one more point right here. So you can see I'm going down 1 over 3, down 1 over 3, etc. From there, we can draw our line. That is way too thick. Let's get something a little bit more reasonable here. There we go. It's not perfect, but it'll do. So this is our line. So what's really important here is you get the slope right and you get the y-intercept correct. So that's it. That's the graph. For number 4, we've got a word problem. It says you spend $18 on vegetables, carrots cost $1.50, and red bell peppers cost $2. So this equation models the scenario where X represents the number of carrots and Y represents the number of bell peppers. Give 3 possible solutions to the equation in the context of the problem. So what we're really looking for here are values that will essentially work here. So I think the best way to kind of approach this is to construct a little table, X and Y, and just pick some numbers. And the only thing that's really not going to work here, because it's asking for just any 3 possible solutions, is so let's say we buy 0 carrots. Okay, so I'm going to put 0 here. If I buy 0 carrots, then I'm going to have this equation over here, 2y equals 18. And so in that case, if I divide by 2, I'm going to get 9. So if I buy 0 carrots, that means I bought 9 red bell peppers. So one of the coordinates that could work, or one of the possible solutions, could be 0, 9. A line will have infinitely many solutions here, and basically for any x, I'll have a y, but since this is a word problem and there's some context built around it, it's important that the answer makes sense in the context. And what I mean by that is, like, if you get a decimal here, we're not going to include that as a possible solution, because it's not like you can go to H-E-B and buy half a carrot. They're not going to sell that to you. You can't just take a knife into the grocery store and chop a bell pepper in half and expect them to sell it to you at half price. So we're only going to be working with whole numbers here, positive integers. So let's see if we get another one. So like if I plug in 1 into x, and then so this is 1, I'm going to get 18 minus $1.50. That leaves me with $16.50. If I divide that by 2, let's see, what would that be? Let me pull up the old calculator here so that I don't have to rely on my mental math. So let me make sure it's on for y'all as well. There we go. Don't really need, that's an old calculation. We don't need that for anything. So yeah, what I want here, and let me go ahead and move this around. It's down over here so you can see the whole problem. Is, let's say we have 18 minus, let's say we just bought 1 carrot, so minus 150. I get $16.50. Now you might already see where this is going, but if I divide that by $2, that means I'd have to buy 8 1/4 bell peppers, which obviously that's not going to work, right? Just like what I was talking about earlier, you can't go in, slice off a sliver of bell pepper and expect them to only charge you for whatever percentage you cut off. They're just going to either sell you 1 or 2 or some, like a whole number of bell peppers. So 1 is not going to work. So let's try 2. And what we're going to notice is we're really going to want these even numbers so that the division works out a little nicer. So let's see here. Go back here. So yeah, I'm just going to delete the 1 because that's not going to work, and I'm going to jump to 2. So if I get 2 carrots, 2 times 150 is $3. So 18 minus 3 is going to be 15, and that's not an even number. So if I divide that by 2, that is, once again, unfortunately, going to give me a decimal. So we don't want that either. Same thing's going to happen for 3. If you continue this process, you'll eventually figure out that 4 is going to work. And then what you're going to notice is that basically each one of these is going to have to be a multiple of 4. Because 4, oops, oh, where did I go? How did I get all the way down there? If I plug in 4, then I get 4 times 150, which is 6, but I'll just show that to you here, especially with as much emphasis I've given you on using the calculator. So we're going to subtract that from $18. That's going to give me 12. Then if I divide that by 2, because each bell pepper costs $2, I get 6. So if I buy 4 carrots, I can get 6 bell peppers. And if I'm following this pattern, I'm going to expect that the next solution here is going to be 8 comma something. So if I plug in 8, and I do 8 times 150, that gives me 12. If I subtract that from the amount of money I spent, which is $18, that leaves me with $6. And since each bell pepper costs 2, if I divide by 2, that gives me 3 bell peppers. So 3 possible solutions here would be 0.9, 4.6, and 8.3. And as far as like reporting these in the context of the problem, one way to say this would be, you could say, I bought 0, or I could say I could have bought 0 carrots and 9 bell peppers, right? Or you could say the same thing about buying 4 carrots and 6 bell peppers. And finally, the last one, you could have bought 8 carrots and 3 bell peppers. So the very last one, I think if I continue this on and I get 12, I wonder if that will work as just like another possible solution here. I think it will. So that's already 18. So like the next possible answer here would be 12, 0. And so it'd be one of those 4 possible solutions. But I just am going to list the first 3 because it's only asking for 3 of them. Number 5 says write an equation of the line that passes through this point and is parallel to the following line. So if it's parallel to it, that means that the slope has to be the same. In other words, the slope, or the m value, has got to be -2/3. Okay, so that's going to be important. And it passes through this point, which indicates that we're going to have to write this in point slope form. Here's my x1, my y1. And so now I've got the m, I've got the x1, I've got the y1, so now I can start to write my equation, which will be y minus 4 equals -2/3 x, parentheses, sorry, minus 5. So I got my x1, y1 is 5, 4, and then my slope is -2/3. Now, that is the equation of the line, and that's fine, but the follow-up here is that we need to write it in slope-intercept form, and that's going to take 2 steps. So the first step is going to be to distribute the -2/3. So that'll give me essentially the same thing on the left side, but -2/3 x minus 10/3, or actually, no, if I'm multiplying a negative by a negative, that should be positive. And you can use your calculator there too, just trying to save a little bit of time here. And then if I add 4 to both sides, so I'm adding 4 to cancel it out on the left, I need to add it to the right. Now here, I'm not as confident in my abilities, so I am going to pull up the calculator to hopefully get this one right, which is I need to do 10. Let's see, what was it? 10/3. So I'm just going to kind of store that, and I'm going to add 4. Now, if you get a decimal, which I am expecting a decimal here, and you want to convert that to a fraction, you're going to hit the math button, and then you're going to hit enter, enter. Okay, and so I get 22/3. So let's go ahead and fix that. So we've got y equals -2/3 x plus 22/3. Number 6 is a similar problem. It says, write the equation of the line that has a slope of 6. Okay, so that's given to me right off the bat. And has a y-intercept of -1/3. And if I'm writing this in slope-intercept form, that's actually really good because I already have the slope and the y-intercept. So I'm not going to have to rearrange the equation or anything like that. So I'm going to get 6x minus 1/3, and that's my equation. For number 7, it says, write an equation of a line that has a slope of -6 and passes through this point. Write it in slope-intercept form. So basically, we're going to work this out kind of the same way we did number 5. So I'm actually just going to copy that work down here and just start changing the numbers to be what they need to be. So my point here, -9, means this is going to be x minus -9 and y minus 7. We don't want to write minus a negative, so we're going to change that to its equivalent, but a little bit simpler operator, which is just plus. And then my slope is -6 here. So the next step is, oh, it didn't change. It should be -6. There we go. So now what we need to do is distribute the -6 to both x and to 9. This didn't really translate very well. I'm just going to go ahead and delete that. Yeah, I'll just rewrite it. I don't really like how that looked. So yeah, we're going to multiply -6 by x and -6 by 9. This is still going to be y minus 7, and I might as well just delete all this for now. Y minus 7 equals -6x, and then we have -6 times -9, which is going to be -54. The last step here will be to add 7 to both sides. So I'm going to combine that with my -54. So -54, oh, accidentally opened something. What is it doing? There we go. So -54 plus 7 is -47. This might be another case where you double check your arithmetic in the calculator. So we've got y equals -6x minus 47. For number 8, really the same thing, okay? Same thing as we did on this one. So once again, I'm going to do kind of what I did earlier, which is just copy and paste the work because the process will be identical. Just that in this case, the slope is going to be -2. And the coordinate is going to be -2, 3. So this would be like x minus -2. So once again, that becomes +2. And then we got y minus 3. Once we distribute the -2, we're going to have -2x minus 4. And then I need to add 3 to both sides. So I'm going to get -2x minus 1. And that's number 8. Okay, let's move on to the next page here. Number 9. For number 9, it says for the equation y equals 5/4 x plus 9, find the value of x when y is 14. So they're giving us one of the variables and we're trying to find the other. It's almost like giving half of a solution and trying to figure out what the other half is. So all you have to do here is just substitute y with what it is, 14, and we're going to solve for x. So I'm just going to start with this equation here. And then I will subtract 9 from both sides. 14 minus 9 is 5. 5 equals 5/4 x. At this point, you have two choices. You can either try to divide by 5/4, which is great if you've got a calculator. If you're trying to do it mentally, the easier way is going to be to multiply by 4 and then divide by 5. So you can do it either way. If you're trying to do it mentally like I am here, it's probably easier to take it one step at a time. But if you're using a calculator, just by all means do 5 divided by 5/4, and you'll still get the same answer, which is 4. For number 10, it says write a linear function with these functional values. F of 1 is -2, and f of 4 is 5. So just as a little reminder, this is just function notation for coordinates. Like this is saying that 1, -2 is a solution to the equation or a point on the graph. And f of 4 equals 5 is saying that 4, 5 also is a solution to the equation or a point on the graph. With these 2 points, we can find the slope. And then we'll use point-slope form to actually write our equation. Now, this doesn't say that we have to rewrite it in slope-intercept form, so we're going to be safe to just leave it in point-slope form. Now, if the arithmetic works out easy, I might just take it all the way, but if we got to deal with fractions, then I'm just going to leave it in point-slope form. So here, my change in y here, to go from 5 to -2 is going to be -7. And then to go from 4 to 1, I'm going to subtract 3. So yeah, this is going to end up to be kind of a nasty fraction. It's not going to be a whole number here. So I'm just going to leave it as, that's kind of hard to read, isn't it? I'm going to rewrite that 3 there. But yeah, so I'm just going to leave it in point-slope form. So my y minus y1, and you can use either of these 2 points. I'm going to go with the one that doesn't have any negatives in it, just so it's a little bit easier to put together. So I'm going to use the 4, 5 as my x1, y1. So I'm going to have y minus 5 equals the slope, which is -7 over -3, but a negative divided by a negative is positive, so this ends up just being 7/3. Times, let's see here, x minus 4. And that's it. Okay, you could change this to slope-intercept form, but the question is just asking to write an equation, and that's what we've done. For number 11, it says write an equation of the line shown, and what we see here is we have a horizontal line. So horizontal lines are always going to be written the same way, which is y equals, and then whatever the y coordinate is for all the points on the line. So all of these points along this horizontal line are going to be something comma -2. You can see like 0 comma -2. 1 comma -2, 2 comma -2, 3 comma -2. All of the y coordinates are -2, so we write the equation just as y equals -2. For number 12, it says find the missing coefficient, or b, in the equation of the line shown. So it looks like here we have to, what we're going to have to do is rewrite that equation in slope-intercept form and then try to figure out what it is from there. So I'm going to start with just the equation that it gives us. I'm going to subtract 3x from both sides and then divide everything by b to get y equals -3 over b, x, oh boy, b stands for oh boy, and then plus 6 over b. So this right here is what we can actually use either one here. This needs to be the slope, this needs to be the y-intercept, and we actually have information on both, so you can set up either equation. I think all the ones that we did in class and on the homework, we just focused on the slope, but you can use the y-intercept if you know what it is. So like we know the y-intercept is supposed to be -2, so we could set this equal to -2, but we also know that the slope is going to be up 1 over 1 or just 1. So I guess I'll set up both. You could either do -3 over b, which is the slope, needs to be 1, or you could say that 6 over b needs to be the y-intercept, which is -2, and if we work these out correctly, we should get the same answer. So here, if I multiply both sides by b, I get -3 equals b. If over here I multiply both sides by b, I get 6 equals -2b. And then dividing by -2 will give me the same thing. So in both of these cases, I do get -3 as b, and that's my answer. And you know, if you have both of these pieces of information, it doesn't really hurt to do it both ways. That way, if you get the same number on both of these, then you know you did it right. Okay, so number 13 says write an equation in slope-intercept form. Now, what's a little tricky here is it's not really clear what the y-intercept is. It looks like it might be 1, 2, 3, 4, 5, maybe 7, maybe not. It might be a fraction. We're going to have to start with point-slope form first, and then we'll go to slope-intercept form. So I'm going to set this up, and I can pick either one of these 2 points. I mean, you're really technically allowed to pick any point on the line. But these are labeled, so I'm going to go ahead and pick, I'll go with 2 comma 3. So I'm going to pick out this point right here as my x1, y1. And so I've got y minus 3 equals the slope, which if I'm going down 2 over 1 would be -2 times x minus 2. All right, this coordinate right here, that's my x1, y1. That is the 2 comma 3, that's where I'm getting the 2 here and the 3 here. And then the slope, I'm going down 2 over 1. That's where this slope is coming from. So to put it into slope-intercept form, I need to multiply -2 by both of these. I'm using the distributive property there. And so I get -2x plus 4. And then if I add 3 to both sides, I'll get -2x plus 7. So it actually ended up being 7, which is kind of where I was estimating, just kind of eyeballing where it might hit. You don't want that to like give you your answer, but it is a good idea to kind of get just to kind of guess where you think it's going to be. That way, if you get an answer that's close, it can increase your confidence that you got it correct. Number 14, we got a word problem. It says, the city council members of Austin want to construct a new boardwalk along the lake. They want the boardwalk to be perpendicular to the road leading to the lake. Write an equation that would represent the boardwalk. Okay, so these are perpendicular, and just as a reminder, perpendicular means that they intersect at 90 degrees, but more importantly, it means that their slopes are opposite reciprocals. Now, we have a lot of information about this line, so we don't really need to know anything about this other line or the fact that they're perpendicular. It's just not necessary information, because all we're trying to do is write an equation of this bold line here. So the slope, like if I notice that there's a point here at -8, it's going to be down 4 over 8. So down 4 over 8 will reduce to 1/2. So -1/2 x, and the y-intercept is -4. There you go. That's really all there is to it. Yeah, if this line wasn't so obvious like where it was, we might have to take a different approach, but because it's really clear what the y-intercept and the slope is, you can just go directly to that. Number 15, write an equation of the line that has a slope of 4 and a y-intercept. All right, if we're writing this in slope-intercept form, y'all know the drill at this point, hopefully. The slope is 4, so that's going to be my coefficient to x. The y-intercept is 9/7, and I think this is almost like trying to trick you because usually the slope is the fraction and the y-intercept is the whole number. But it doesn't have to be that way. That's just how they're, we see a lot of examples that are set up like that. But the y-intercept could be a fraction. The slope could be a whole number. There's no rules about that. All right, let's move on to inequalities. Okay, so now we're moving on to that day 3 stuff, and it looks like these problems are not necessarily in the order in which we learned it in the unit. They're kind of mixed up, and that's kind of how the test is going to be, where the problems are just kind of all mixed in together. So let's see here. Number 16. Oh, something came up here. What is going on? Number 16, we are graphing the inequality. So there's a couple things to note here before we really jump into it. It says strictly less than, so we're going to use open dots, and we're going to use a dotted or a dashed line to indicate that we don't want to include the points on the line in our solution set. And since it's less than, we're going to shade down. The rest of it we sort of graph the same way that we've been doing, which is to start with the y-intercept and then use the slope. So we'll go ahead and do that. We're going to have a point at 0, 2. That's the y-intercept here. So, and I'm going to do that with an open circle. And then the slope is -1, so I go down 1 over 1. I'll do another open circle there. I wonder if this might be easier if I use the shape thing and Cami here. Oh, it's not a square, we want a circle. Here we go. So we've got a point there, go down 1 over 1, down 1 over 1. Yeah, this is way easier than trying to hand draw it. And so forth. You don't really need all the points there. That's good enough. And then, well, you know what? It's pretty easy. I'm just going to go ahead and take it all the way. Might as well. What else have we got going on today? All right, so it goes all the way. Now I can go ahead and draw my line, but I don't want to draw a solid line. I'm going to draw like a dashed line. So I don't think that's an option here in Cami, so it's going to look a little sloppy here. I apologize about that. But basically I'm just trying to draw these lines to show that I'm not connecting the dots. And really what I'm trying to communicate here is that the solutions to this inequality are going to be in the shaded region only, not actually on the line. okay, because the y doesn't equal the line, it's going to be below the line. So at this point, we're going to shade in everything below the line. How do I want to do that here? What's the, I'm just going to get a real thick mark here, and that's not that's not really what I want. There we go, just to kind of help me here. And I'm going to shade everything that's below this line. So basically, the idea being that every point in this region, if you pick any combination of x and y, which corresponds to a point in this region, if I plug that into x and to y, into the inequality, it'll be a true statement. So like 0, 0, for instance, is in the shaded region. If I put 0 into x and 0 into y, I get 0 is less than 2, which is true. Yeah, and that's going to be true for any combination of x and y in the shaded region here. It will not be true for the points on the line, like 0, 2, for instance. If I plug in 0 here, 2 is not less than 2. If it was less than or equal to, it would count. And so that's why we differentiate between the dotted and the solid, the solid lines. Number 17 says it has a slope of 3/2 and contains the point 3, -7. So here I'm just going to plot the point 3, -7. Oh, come on. Really? That's going to be off the grid? Well, that's kind of annoying. Yeah, let's see. 5, 6, 7 is going to be somewhere down here. 3. This is going to be totally... Oh, gosh. I think what we're going to have to do here, y'all, is... how do we want to handle this? I think to just make this... Yeah, because even if it's at 3, -7, if I go up 3 over 2, you're barely even going to see the line on here. That's very disappointing. Very disappointing. So I think what I'm going to do here, I think the way to go is just make a change to the question. Okay, and that way we can still have the experience of going through how you do this. Yeah, so what I'm going to do, I'm going to change this to, let's say, instead of -7, let's call this -1. Okay, so we can just make a little change. I can make a little note to remind y'all in class about that, number 17. So 17, we're going to change to 3, -1. Okay, that way we actually have something we can deal with here. So I'm going to start by plotting that point, doing what I would have done anyways had I had a bigger grid. I guess one thing we could have done is just rescale everything, but because we had like 3, if it was an even number, I think it would work better. 3 and 7, there's no common factor there, so it's just not the grid. Trying to rescale it is going to be kind of messy. Yeah, it's just not a good situation there. So that's why I'm going to go ahead and change this. So 3, -1 is right here. And then, so since the slope is 3 over 2, I'm going to go up 3. 1, 2, 3 over 2, plot that point. And I can also continue that backwards. So down 3 to the left 2. So yeah, sorry about that one. That's my bad. I got to wonder if maybe that's a typo to begin with. I don't really remember, to be quite honest. But we can still, make a little change here and just move on with our life. Okay, so here's what the line looks like. Now, if you've got an equation like x equals a certain number, we talked about what that looks like, which is a vertical line that passes through the x-intercept of 2. So I can just draw that vertical line there. That's all there really is to it. That's x equals 2. And what this represents is all the coordinates where x equals -2. So like you see, we've got these points like at 2, 0 and 1, 0. I'm sorry, 2, 0, 2, 1, 2, 2, 2, 3. With all the points on this line, the x coordinate is 2. And that's what this equation means. For number 19, it says write an equation of the line that passes through this point. So right away, I know I'm going to have to start with point-slope form. Okay, so this point and is perpendicular to this equation. So if it's perpendicular, that means that the slope is going to be the opposite reciprocal of the other line. So the slope in this case is going to be the opposite reciprocal of 1/4. And so that would be negative, the opposite, and the reciprocal would be 4/1, so the slope is -4. Okay, this over here is my x1, y1, and so now I'm ready to write my equation. Y minus -6 is equal to -4 times x minus -4, and we've talked about this before, which is if you've got minus a negative, don't leave it like that. Just change that to plus. It means the same thing. So now I'm going to distribute that -4 and get -4 times x minus 16. And finally, I'm going to subtract 6 from both sides. So I'm going to end up with y equals -4x. Let's see, -16 minus 6 would be -22, I believe. I want to double check that, but I think I'm pretty sure that's right. And yeah, so there is your equation in slope-intercept form. It's going to pass through this coordinate, and it's perpendicular to this line. For number 20, it says find the slope of the line. So that's basically like number 1, okay? We're doing basically the same thing here. We're just checking our rise over run, and the rise here is going up 1, 2, 3. Okay, so up 3, over the run, which is 2, and that's it. Okay, so you can see we're going up 3. Let me use a different color here so it doesn't blend in with the red. Up 3, over 2. Yeah. So that's where I'm getting that from. So it's a change in y over change of x. I go in a little bit more detail. If you skipped over that first problem, I talk a little bit more about rise over run and change in y over change of x. So if you want more details, go check out that first problem. For number 21, we're trying to find the slope of the line that contains these 2 points. So again, we're just doing rise over run, except we don't have a picture to work with here. So we're just going to be thinking about change in y over change in x. And so I'm just going to stack these two. This is kind of how I showed you all to do it in class. And first we'll look at the change in y. The change in y here is going to be, like going from 1 to -9 is going to be minus 10. And then to go from 6 to 10, I've got to add 4. Okay, so this is my change in y, or my delta y. And, oh gosh, I should just really type that. And this is my delta x. And since slope is change in y over change in x, my slope is going to be -10 over 4, and that will reduce to -5/2. All right, there's number 21. So let's move on to number 22, where we're looking for x and y intercepts. So the x-intercept is where the graph crosses the x-axis. So we're going to report back this coordinate right here for the x-intercept. And then the y-intercept is going to be up here. The y-intercept is where the graph crosses the y-axis. So the x-intercept, and it's a good idea to usually write these as a coordinate, 2, 0. The y-intercept is going to be 0, 3. So once again, we're just identifying those 2 points where the line is crossing over the axes. Number 23, graph the inequality y is greater than 2. So this is going to be, the line that we're going to draw is going to be a horizontal line, like if you had, like if we were to graph y equals 2, it would just be like this line right here. Now, I'm not going to graph that yet because this is actually a greater than 2, not equal to. So what we have to ask ourselves when we're graphing these inequalities is, number 1, how are we going to graph the line? And by that I mean, are we going to graph a solid line, which indicates that solutions lie on the line, or a dotted line, which indicates that solutions do not lie on the line? And since this is greater than and not equal to, we're going to draw a dotted line. So instead of drawing that just solid horizontal line, I'm just going to kind of do my best here to do a dotted line. which kind of goes along, the dotted line is kind of like the two-dimensional analog to the open dot, which is indicating kind of the same thing for when we graph these one-dimensional inequalities on a number line. In this case, we'd have like a open dot, and since y is greater than 2, we're going to shade up. But yeah, so the open dot, the dotted line kind of go together. And if you have a closed dot, if this was something like greater than or equal to, where we want to include the points on the line as solutions in our set, then we would draw it solid with filled in dots. So from here, I'll go ahead and just shade in this region up here to show that the solutions to this inequality can be found anywhere in this region. So basically you can pick any point like 0, 10 and substitute, no, there's no x to substitute the 0 in, but if we substitute 10 into y, 10 is greater than 2, so that's true. So basically all the coordinates up here have a y value that's bigger than 2. On number 24, we're going the other way. Instead of being given an inequality and asked to graph it, we're given a graph and are asked to write the inequality. So on this one, we can note that the y-intercept of the line here is -3, and the slope is, well, actually the slope is also -3. Those aren't always the same, so that's just kind of coincidence for this problem. So if we were just writing the equation of that line, we would say it, and let's make this a little bigger so you can see it a little easier. I just realized that my head's probably covering this one. Let me move that over a little bit. Yeah, so anyway, if we were writing just the equation of the line, it would be y equals mx plus b, or in this case, -3x plus 3, or -3. But this is supposed to be an inequality, right? We're not just writing the equation of this line. We want to write an inequality so that everything in the shaded region would be a solution to that inequality. So really the only thing to do here is recognize that, number one, this is a dotted line. So we're not going to actually include the points on the line in our solution set. So it's not going to be equal to. But since it's shading up, meaning like if you pick any point on this line, the shaded region is above it rather than below it, then this should be greater than. So here's our inequality. That's it. So just as long as you can write the equation of the line, I would start with that and then analyze what the symbol should be. You don't have to do it in that order, but that's just kind of what works for me. Number 25 says write an equation of the line that has a slope of 3 and passes through this point. So we've already done a bunch of these. You can kind of scroll back to some of the earlier problems where I give a little bit more detailed explanation here. But basically what we want to do is put this into point slope form first. Y minus -3 equals the m, which it said was 3, times x minus 2. I don't like this minus a negative, so we're going to change that to plus. And so this is the equation of the line in point slope form. And as we've seen with several of the other problems, there's 2 steps to get this into slope-intercept form, which is where we want to be. And that is, first, we're going to distribute the 3 here. So that'll give me y plus 3 is equal to 3x minus 6. And then if we subtract this 3, or subtract 3 from both sides to move this 3 essentially over here, -6 minus 3 would be -9. So we get y equals 3x minus 9. And that's going to be our slope-intercept form. So this is the point slope form that we start with. You just distribute, subtract the constant that's over on the left-hand side, and you should have your answer. Number 26 is very similar, except it doesn't just give you the slope. Like number 25 just told you what the slope was. Oh, I'm still dealing with that. Let's fix that. Yeah, so 25 told us what the slope was. 26 does not tell us what the slope was. It still gives us a point, but we have to actually figure out the slope. So the way I like to figure out the slope is just kind of writing these coordinates stacked on top of each other, and then analyze the change in y over the change in x. So the slope, let's see here. If I'm going from 5 to 9, my change in y, okay, my delta y is plus 4. Okay, because I got to add 4 to 5 to get to 9. And then if I'm going from 9 to 4, I have to subtract 5. So my delta x, or my change in x, is minus 5. So that means that my slope, which is change in y over change of x, is 4 over negative 5, or a better way of saying that would just be, let me bring this up a little bit, would just be negative 4/5. It means the same thing. All right, so now I've got the slope, I've got a point, so now I can basically just copy the steps that I did on the last problem, but plug in the correct numbers. It doesn't really matter which of these 2 points you pick. I guess I'll go with the 4, 9, although, again, it really doesn't make a difference. So I'm going to change my x1 to 4. I'm going to change my y1 to 9 here, and the slope I had was negative 4/5. And I think I'll just delete the text on, I probably just don't want these other two, so that you're not too confused on what's going on. So just like with the last one, I'm going to distribute the negative 4/5. So that's going to give me negative 4/5 x, and then 4 times 4 is 16. And I have a negative times a negative, so that's positive 16/5. The last thing to do is to add 9. And this is another case where, since we're trying to add fractions here, you might as well use a calculator to make sure you get it right. 9 in terms of fifths would be, what would that be, 45/5? Is that right? I think so. I might double check that. And you know what? I'm all talk over here. Let me just go ahead and break out the calculator. Make sure you guys can see it. Here we go. Yeah, no shame in using the calculator, y'all. You get to use a scientific calculator on the CLEP test, so make sure you know how to use it, really. Not sure why it's getting cut off there. It's kind of weird. Okay, well. Oh, there we go. Okay, that's strange. So what we're trying to do here, we're trying to compute, where could be a good place for this? I guess I'll try to put it up over there. Is 16/5. So I'm going to do alpha y equals 16/5. And I'm just going to do plus 9, just to make sure. If 45 and 16, if I was right, it would be 61/5. Yeah, there we go. Okay. So I should have probably just trusted my gut there, but I wanted to make sure it didn't get it wrong. Okay, so 61/5 is going to be our constant. That is our y-intercept, and we're done with that one. Okay, so this equation represents a line that will pass through both of these required points. Yeah, and that's it. Number 27, find the x and y intercepts of negative x plus 3y equals 9. So some teachers call this the cover-up method, but basically what you're going to do is you're going to substitute 0 into one of the variables to find the other intercept. So to find the x-intercept, I'll start by substituting in 0 into y and then solving for x. So negative x plus 3 times 0 equals 9. Now 3 times 0 is 0, obviously. So we can get rid of that term. Negative x plus really nothing equals 9. So that means x is negative 9. So if x is negative 9, that means our, come on, there we go. If x is negative 9, then our solution, or our intercept here, will be at the coordinate negative 9, 0. And that's how you get the x-intercept. And you get the y-intercept very similarly. Really the only difference here is that, what happened there? The only real difference between the x and y-intercept is that instead of substituting in 0 for y, you're going to substitute it in for x. But the rest of it should be basically the same. So yeah, here's how I got the x-intercept, but we're going to change that. And instead of plugging in 0 here, I'm going to leave that y, and we're going to plug in 0 here. So you have negative 0, which is just 0. So we can kind of ignore that. Plus 3y equals 9. And then if we divide both sides by 3, we get y equals 3. So the y-intercept is going to be at 0, 3. Now, if you're asked to graph an equation that's in standard form like this, this is going to be the strategy you want to use. You're going to find the x-intercept and the y-intercept by substituting 0 into the other variable and solving. And then once you have those 2 points, you can plot those on the grid. This doesn't ask you to do that, but if you are asked to graph a line that's in standard form, that is the strategy you want to use. You want to just basically plot the 2 intercepts, connect the dots, and you'll have your line. Number 28 says graph the line that has a slope of 2 and contains the point 2, 2. So let's plot the point first. 2, 2 is going to be right here. And if the slope is 2, anytime you have a slope that's a whole number, it's kind of good to think about it as being that over 1. So you can, so that you remember that that the rise over run here, or your change in y over change of x, is 2 and 1. So we'll go up 2 over 1 to find another point. And you can continue that pattern backwards as well once you identify what it is. And I'm just going to fill up the grid here with points that are going in that line. And then I'm going to connect the dots. Ooh, that line's a little thick. Let's bring that back a little bit. There we go. That's close enough. So that line goes through 2, 2 and has a slope of 2. All right, number 29. Here we're trying to graph the inequality x is greater than or equal to -2, and since it can be equal to, we're going to draw a solid line. X equals -2 is going to be a vertical line going right through the x-intercept -2 and represents all the coordinates where the x value is -2. And this says that not only is x equal to -2, but it could be greater than -2. So this is another case where we want to shade. And when it's greater, with this vertical line, it's kind of hard to imagine shading up or down. It doesn't really make sense in this context. So and for this one type of inequality where it's just x and there's no y in it, and you have this vertical line, instead of thinking about shading up or down, you want to think about shading left or right. And when it's greater than, you're going to shade to the right. So you're going to shade all these, and all the points that are in this region here represent coordinates where the x value is greater than -2. So like 10, 14, for instance, has an x coordinate that's bigger than -2. Right? All the points in this region should. Okay. Number 30 here says, is 5, 8 a solution to the inequality? So here all we need to do is just test to see if I plug in 5 into x and 8 into y, do I get a true statement? So I'm going to actually just put like a little question mark here. We don't know if it's greater than or, maybe I'll just do like a little question mark out to the side. We don't know if that's true yet. We need to test it. So, scroll back down here. Okay, so 5 minus 7 is going to be -2. And 8 is bigger than -2. So we can say yes, in fact, that 5, 8 is a solution. Basically what that means is that that point is going to either be on the line or in the shaded region. So let's see, and we can tell it's going to be in the shaded region versus the line because those two numbers are not the same. If it was like 8 is greater than or equal to 8, then we would know it's on the line. Here we're not expecting it to be on the line anyway because it's just strictly greater than. So 5, 8 is a solution to the inequality. For 31, it says the equations of 4 lines are given, identify which lines are parallel. So parallel lines will have the same slope, so basically what we need to do is check the slope for each one. So maybe I'll make a little table here. Not a table, but just like create a little column here. And for line 1, we can see that the slope here is going to be -7 because this is in slope-intercept form. And yeah, so there's the slope right there. It's just -7. Here we go. So for line 1, the slope is -7. For line 2, we need to rearrange this. So I'm going to do a little extra work over to the side here, because what I need to do is get this equation into slope-intercept form so I can know what the slope is. So I'm going to start by subtracting x from both sides, and that's going to give me 1. Let's make this a little smaller so it'll fit here, y'all. Maybe we'll go down to 18-point font. Hopefully you can still see that well enough. So yeah, we're going to subtract x from both sides, and that's going to give me -1/2, not 1/2, but 1/5 y equals -x minus 6. And then I need to multiply both sides by 5 to isolate y, and so that's going to give me -5x. Let's see, 6 times 5 would be 30, so minus 30. So the slope on this one is going to be 5. I'm sorry, -5. So they're not parallel or perpendicular or anything like that. But we don't know the other ones yet, so I'm just still going to make a note of that. For line 3, we see that -5 is the slope here. This one's in slope-intercept form, so there's not really anything to go on about there, as long as you know how to identify the slope in a slope-intercept form equation. You should be good there. Now, line 4 is in point slope form. So we don't really need to change it because all we're doing here is identifying the slope here. Slope in this one is -1/7. So if we are looking for the lines that are parallel, I was kind of wondering if maybe, let's see, can we make this font a little bigger so it, yeah, that's fine. It's fine the way it is. Maybe I could do like a little space here. No, that's too much of a space. Here, I'll do that. There we go. So the two that we're really interested in here are going to be the two that have the same slope. So that's going to be these two equations here. So these are going to be the two lines that are parallel. So if I'm going to answer this question, I can say lines 2 and 3 are parallel because they have the same slope. All right, well, that takes us to the very last page, and we're finally almost done with this one. It says the equations of 4 lines are given. Identify which lines are perpendicular. So same kind of idea as we did before, as we had before. So I'm just going to kind of copy. Well, there's not really much typing there. So I'm going to create a little column here, find the slopes of these lines, and we're looking for ones that are perpendicular. So we're not looking for ones that have the same slope, but we're looking for ones that have either opposite reciprocal slopes or you know, really the only other case where you can have perpendicular lines other than that is if you have like a horizontal and vertical line. So the slope of the first one, now y equals 1, that's a horizontal line. So the slope is 0, and I'm just going to make a note that it's horizontal. Okay, for line 2, the slope is going to be 1/4, and we can see that because it's in slope-intercept form. So that one is just 1/4, or just a quarter, basically. Now the next one is, so that's a vertical line. So that's actually undefined slope. How about that? And that is a vertical line. So that one is going to be a line that is perpendicular to line 1. But let's check this last one just to see if maybe we get another pair. And yeah, actually we do here. So the slope here is going to be -4. And so -4 is the opposite reciprocal of 1/4. So we can see lines 2 and 4 are also going to be perpendicular. So we actually get 2 pairs of perpendicular lines here. Interesting. So we'll say lines 1 and 3 are perpendicular. Okay. Also, lines 2 and 4 are perpendicular. All right, so yeah, just a little note here about the horizontal and vertical lines. Make sure you know those are perpendicular. They don't, the fact that this is undefined means these are technically not like opposite reciprocals. But if you have a horizontal and a vertical line, you should know those are going to be perpendicular too. This is kind of a special case here. But otherwise, if there any other line, the slopes, like you can see 1/4, -4/1, are opposite reciprocals. So that's another case of where you could have perpendicular lines. Last couple of questions here. 33 says graph the inequality. Now this one, I think what I'm going to do is change this to slope-intercept form. I'll start by adding 2x to both sides. And if I add 2x to both sides, I'm going to get 8y is greater than positive 2x minus 6. And then if I divide everything by 8, I'm going to get, let's see, 2 divided by 8 reduces to 1/4 x minus 6/8, which reduces to 3/4. Ugh, that's not very nice. But it is what it is. All right, so that means that my y-intercept is going to be right here. -3/4 is right around here. And then my slope is up 1/4, so I'm going to go up 1/4, puts that point like right about there. And I could go down to the left 4, just like barely staying off of that horizontal line there. And then I could draw my line. Now this is strictly greater than, so I don't want a solid line. In fact, I probably should have made those points. I'm going to go back and change those points to make them open circles. You can, I see a lot of textbooks where even on a problem like this, they'll leave them closed, and there really shouldn't be. I think it's just, I don't know why they do that, to be honest. Okay, so here we go. We got our dashed line here, and it's going to look a little sketchy here. I wonder, I don't think Cami has a way for me to draw like a straight dashed line. I know I could do that like in Microsoft Word, but I don't think Cami has that ability. Oh, look at that. It's been there the whole time. Okay, well, I'll better luck next time. I should have at least checked. Oh well. Okay, so that's fine. So now we're going to shade, and since it's y is greater than, we're going to shade above. I can't believe I didn't check that earlier. I've been talking about it so many times, and I just assumed it wasn't there. Okay, so yeah, so we're going to shade above, so all this should be shaded in. And what this is saying is that all the points in this region will be solutions to the inequality, meaning they will satisfy or make that statement true. All right, so just kind of shade the best you can here. You don't have to get every little square inch of this thing covered, just enough to kind of show you what you're trying to communicate clearly what you're trying to do. Number 34, same kind of deal here, except this one's already in slope-intercept form, so we're going to end off with a nice one here. This one I'm going to go with the solid dots and the solid line because of the equal to part of it. The y-intercept here is 4, and the slope is -2. So I'm going to go down 2/1 and continue that pattern all the way down. And there's my line. That's a little thick there. Let's maybe make that a little thinner. There we go. That's a little better. So here's the line, roughly. Okay, so it says y is greater than -2x plus 4. So I'm going to shade in that upper region. It's going to be over here. And that is it. So make sure you feel comfortable with all the problems on this review. If you do that, you should be in pretty good shape for the test. As always, let me know if you guys need any help outside of that, and just reach out, and I'll do the best I can to get you up to speed. Other than that, y'all have a great day, and I'll see you next time.